this session, we will discuss about batteries, fuel cells, and Faraday's laws of electrolysis. A battery is a device that converts chemical energy into electrical energy. In a battery, reaction between the chemicals takes place. The main components of a battery are electrodes and electrolyte. The electrodes are classified into two, anode and cathode. The cathode is a positive terminal where the reduction occurs. Reduction means gain of electrons. Anode is a negative terminal where the oxidation occurs. Oxidation means loss of electrons. The functions of electrolyte are: it allows the separation of ionic transport and electrical transport, ions to move between electrodes and terminals, current to flow out of the battery to perform work. This is the basic overview of battery. Battery has a metal or plastic case. Inside the case are cathode, anode and electrolytes. Separators create a barrier between the cathode and anode. The current collector brass pin in the middle of the cell conducts electricity to the outside circuit. Batteries are classified into two, primary and secondary. A primary battery can be used only once, that is, it is non-rechargeable and disposable. The chemical reactions occurring in a primary battery cannot be reversed. The primary batteries are used when long periods of storage are required, and the primary batteries have lower discharge rate than secondary batteries. The primary batteries are used in smoke detectors, flashlight and remote controls. On the other hand, secondary batteries are rechargeable. The reactions occurring in a secondary battery can be readily reversed. The secondary batteries are very similar to primary batteries except the fact that redox reaction can be reversed. In the secondary cells during recharging, the electrodes undergo opposite process than discharging. The cathode is oxidized and electrons are produced. The produced electrons are absorbed by the anode. Thus, there are two basic types of batteries, primary and secondary. Primary batteries are single-use and cannot be recharged. Dry cells and most alkaline batteries are examples of primary batteries. The second type is rechargeable and is called secondary battery. Example, lead storage battery and nickel cadmium cell. We will study about all these batteries and their functioning in detail. First, we will study about dry cell. A dry cell consists of a carbon rod which acts as the positive terminal, also called cathode, whereas the zinc casing of the battery acts as the negative terminal or anode. The cathode is a carbon graphite rod surrounded by powdered manganese dioxide and carbon. The space between the electrodes is filled by moist paste of ammonium chloride and zinc chloride. The half reactions, that is oxidation and reduction, taking place at anode and cathode are given here. The zinc undergoes oxidation and form Zn2+ and 2 electrons. These 2 electrons are then accepted by the manganese, which get reduced from +4 to +2 oxidation state. The ammonia produced in the reaction forms a complex with Zn2+. The cell has the potential nearly of 1.5 volt. It is used commonly in our transistors and clocks. The next primary battery is the mercury cell. It consists of a zinc-mercury amalgam as the anode and a paste of mercury oxide and carbon as the cathode. The electrolyte is a paste of potassium hydroxide and zinc oxide. The half reactions taking place in the mercury cell are given here. The zinc undergoes oxidation and form zinc oxide, water and 2 electrons, and these 2 electrons are accepted by the mercury oxide and then undergoes reduction. The overall reaction taking place in the mercury cell is zinc plus mercury oxide gives zinc oxide plus mercury. In this reaction, zinc is oxidized and mercury is reduced. The cell potential of a mercury cell is approximately 1.35 volt and will remain constant during its life. The mercury cell is suitable for low current devices like hearing aids, watches, etc. Next, we will discuss about secondary cells. The prime example for the secondary cell is the lead storage battery. The lead storage battery consists of a lead anode and a grid of lead packed with lead dioxide as cathode. A 38% solution of sulfuric acid is used as the electrolyte. The half reactions are given here. At the anode, lead undergoes oxidation and produces lead sulfate and 2 electrons. These electrons are then accepted by lead in lead oxide and get reduced. The overall cell reaction is lead combines with lead oxide and sulfuric acid to form lead sulfate and water. On charging the battery, the reaction is reversed and the lead sulfide on the anode and cathode is converted to lead and lead oxide respectively. The lead storage battery is commonly used in automobiles and in inverters. Another important secondary cell is the nickel cadmium cell, which has a longer life than lead storage cell but is more expensive to manufacture. A rechargeable nickel cadmium cell is a jelly roll arrangement and separated by a layer soaked in moist sodium or potassium hydroxide. The overall cell reaction is given here, where cadmium undergoes oxidation and nickel undergoes reduction. These batteries are used in cordless and wireless telephones, emergency lighting, etc. Next, we will discuss about fuel cell. Fuel cell is a device that converts chemical energy from a fuel into electrical energy through a chemical reaction with oxygen or other oxidizing agent. There are four main parts for a fuel cell. They are anode, cathode, electrolyte, and a catalyst. At the anode, a catalyst oxidizes the hydrogen fuel into positively charged ion and negatively charged electron. At the anode, the catalyst oxidizes the hydrogen fuel into positively charged ion and negatively charged electron. The electrolyte potassium hydroxide allows the protons to travel through the cathode but blocks the electrons. Thus, electrons travel through the wire, creating electric current. The ions on reaching the cathode reunite with the electrons and the two then react with the third component, that is oxygen, to create water. This is the representation of hydrogen oxygen fuel cell. In this cell, the hydrogen is fed from the anode side where it undergoes oxidation and form 2H plus and 2 electron. The electrolyte then selectively permit the 2H plus ions to pass through the electrolyte and blocking the 2 electrons. The 2 electrons then travel through an external circuit creating electric current. We know that electric current is the flow of electrons. The oxygen is fed from the cathode side, and at the cathode, the hydrogen, oxygen, and the 2 electrons combine to form the water molecule. The half reactions taking place in a hydrogen-oxygen fuel cell is given here. At the anode, hydrogen undergoes oxidation, and the equation is 2H2 gives 4H++ 4 electron. On the other hand, at the cathode, the oxygen molecule combines with the 4 hydrogen ion and 4 electron to form the water molecule. The overall reaction of a hydrogen-oxygen fuel cell is given by 2H2 plus O2 gives 2H2O. Next, we will discuss the pros and cons of hydrogen-oxygen fuel cell. The pros are no waste is produced. We know that the byproduct of hydrogen-oxygen fuel cell is water, and water does not cause any pollution and is helpful to us. No carbon footprint at all. It is quieter than internal combustion engines. Due to no moving parts, the fuel cell is very efficient. The cons are the hydrogen-oxygen fuel cell is very expensive. The energy output is very low. Hydrogen is explosive and hence fuel cells are dangerous. Next, we will discuss about Faraday's laws of electrolysis. Electrolysis is the decomposition of an ionic compound by passing electricity through the molten compounds or aqueous solution of the compounds. Electricity is used to produce chemical changes. The apparatus used for electrolysis is called an electrolytic cell. Michael Faraday, on the basis of his research, investigated electrolysis quantitatively. He found that during electrolysis, the quantities of substances liberated at the electrode depend upon the following three factors. They are quantity of electricity passed, time duration of passing the current at a uniform rate, charge on the ions being deposited. Faraday's first law of electrolysis. The mass of an element liberated on the electrode during electrolysis is directly proportional to quantity of electricity Q which passes through the solution of an electrolyte. If M is the mass or amount of substance deposited or liberated and I is the current in amperes which passes for T seconds, then according to the law, M is proportional to I into T, or M equal to Z into I into T, where Z is a constant called electrochemical equivalent of the substance. If 1 ampere of current is passed for 1 second, then M equal to Z. This means that 1 ampere of current is passed for 1 second, then the mass or amount of substance deposited or liberated is exactly equal to its electrochemical equivalent. The unit of the quantity of electricity is called coulomb. Coulomb is the quantity of electricity passed when 1 ampere of current is passed for 1 second. If Q is the quantity of electricity, then according to Faraday's first law, Q equal to I into T. The larger unit of quantity of electricity is called Faraday. 1 Faraday equals to 96500 coulombs. The quantity of a substance which is deposited when 1 Faraday of electricity is passed through an electrolyte is called 1 gram chemical equivalent of that substance. The electrochemical equivalent of a substance may be defined as the amount of a substance deposited or liberated when 1 coulomb of electric charge is passed through an electrolyte. It is denoted by the symbol Z and the SI unit is expressed in kilogram per coulomb. An example is given here. A current of 0.5 ampere was passed through a solution of copper sulfate for 1 hour. Calculate the mass of copper metal deposited on the cathode. The electrochemical equivalent of copper is given here. The current is given as 0.5 ampere. Time is given 1 hour. We should convert to the standard unit, that is seconds, that is 3600 seconds. Electrochemical equivalent of copper should also be taken in kilogram per coulomb. The mass of the substance deposited is given by W equal to Z into A into T, where Z is the electrochemical equivalent, A is the current in ampere, and T is the time in second. Substituting the values, we will get the answer as 5.929 into 10 raised to minus 4 kilogram. Next, we will discuss Faraday's second law of electrolysis. According to the second law, the mass of different substances deposited or liberated when the same quantity of electricity is passed through different electrolytes connected in series are proportional to their chemical equivalent masses. Consider three different electrolytes, silver nitrate, copper sulfate and aluminum nitrate in their aqueous solutions connected in series. The same quantity of electricity is passed through them. Then the mass of silver, copper and aluminum deposited on their respective electrodes would be directly proportional to their chemical equivalent masses. According to Faraday, if exactly 96,500 coulombs of electric charge is passed through the electrolyte, then the mass of silver deposited would be equal to 108 gram, that of copper is 31.75 gram, and of aluminum is 9 gram, which are their equivalent masses of the elements. The equivalent mass of the element is given by atomic mass of the element divided by valency of the element. The current of 96,500 coulombs is called 1 Faraday, named after the scientist. Thus, Faraday is defined as the quantity of charge which deposits or liberates exactly 1 gram equivalent of the substance. A solution of copper sulfate is electrolyzed for 10 minutes with a current of 1.5 amperes. What is the mass of copper deposited at the cathode? The reaction can be written as copper 2 plus 2 electrons gives copper. That is the reduction of copper. Now we know that Q is given by I into T, where I is 1.5 ampere of current and time is 600 seconds. So substituting in the equation we will get Q equal to 900 coulomb. 2 Faraday of electricity can deposit 63.5 gram of copper. Therefore, 900 coulomb of electricity can deposit 63.5 into 900 divided by 2 into 96,500, and the answer is 0.296 gram.